In this video, after previously starting the engine, we continue powering and testing systems. Power the modular mission computer, store stations, multifunction displays, upfront controls, global positioning system, data link, and place MIDS LVT in the on position. The modular mission computer provides computing power to the avionics and weapon systems. Powering the GPS ensures a correct INS alignment. MIDS is the communication component of Link 16, a NATO tactical data link, and maintains TACAN functionality. TACAN volume is controlled through the Audio 2 panel. The MIDS LVT zero-wise position is used to erase sensitive data. To start a normal INS alignment, set INS to normal. If the GPS is powered, the INS will be in a usable state after 90 seconds, at which point a steady ready indication is displayed on the HUD and DED. Full alignment is complete after approximately 8 minutes. In aircraft equipped with an embedded GPS/INS or EGI, alignment is typically complete in under 5 minutes. Power the left and right hardpoints as required. The left and right hardpoint pylons carry external pods, sniper, lantern, and HTS. Power the fire control radar. When in the powered position, the FCR enters a power-on built-in test mode, which is visible on the MFD. The bit takes approximately 3 minutes to complete. It is then set to standby unless it was previously set to a specific mode. This test is required for the FCR to function correctly. Set the radar altimeter to standby. For the safety of ground crew, the radar altimeter is placed in standby mode while on the ground. The data entry display defaults to the INS page. The INS has started to align. The yellow auxiliary warning flag on the ADI indicates that the EGI/INS is not ready. The flag disappears 60 seconds after alignment has started. Set the HUD as desired. Rotate the symbology thumb wheel to power the HUD and to adjust its brightness. Press the faults acknowledgement button on the FCNP and review the PFLD. PFLD faults should clear during startup as systems come online. The seat not armed light is on. All other caution and warning lights are off. When the caution and warning lights have been reviewed, dismiss the master caution light. To view the MFL, press OSB 14 to view the test page. To clear the MFL, press OSB 3. As the primary onboard systems are now available, set C&I to the upfront controls. To set the avionics as required, the pilot would now place the DTC in the DTC receptacle on the right console. Set the MFDs as desired. The uniform and Victor radios can be set through the DTC presets or manually through the UFC. To set the uniform frequency, press COM1 on the ICP and enter the desired frequency. To set the Victor frequency, press COM2 and enter the desired frequency. Verify the uniform and Victor frequencies on the C&I page. To check continuity for the engine overheat and fire detection systems, place Fire and Overheat Detect in the test position. In the overheat state, the overheat caution light illuminates and fire detection illuminates the engine fire eyebrow light. Overheat detection occurs 100C before fire detection. The lights and the master caution light are illuminated until the button is released. To test the illumination of warning, caution and indicator lights, the warning horn and voice messages, place malfunction and indicator lights in the test position.
Pull up. Altitude. Warning. Jammer. Counter. Chat flare. Low. Out. Lock. Caution. Bingo. Beta. IFS.
If the warning horn and voice messages are not heard, check intercom volume. To test the probe heat monitoring system, place probe heat in the test position. The probe heat caution light should flash 3 to 5 times per second. Probes and sensors are used by the air data system to provide static and total air pressures, AOA, side slip, and air temperature inputs. Probe heat has 3 positions. On, when on the ground, the pitot, fuselage air data, AOA, total temperature probe heaters, and the probe heat monitor are energized. Off, circuits are de-energized. Test, a functional test of the probe heat monitoring system is performed. If the probe heat caution light does not flash 3 to 5 times per second, the system is inoperative. When airborne, the pitot, fuselage air data, AOA, and total temperature probe heaters are on, regardless of switch position. Probe heat is in the off position. Before starting the Flickis test, cycle the stick and rudder to help warm the hydraulic fluid and remove air from the system. To start the Flickis test, place the switch in the test position. The green run light illuminates and flight controls are tested in sequence. During the test, Flickis bit 1 will be displayed on the HUD and the takeoff landing config warning light may also flash. When the self-test is complete, the switch will return to its original position and the run light will go off. If the amber fail light illuminates, the test has failed and the test should be repeated. Flickis bit status is displayed on the Flickis MFD page. Note that the Flickis bit can only be initiated if weight is on the wheels and ground speed is below 28 knots. The DBU selects the Flickis backup software. Place DBU in the DBU position. DBU illuminates on the right eyebrow. The HUD warning message is displayed, and the MFD Flickis page displays DBU. Move the flight controls. Verify correct operation visually. Check that no Flickis lights illuminate, and to end the test, return the switch to the off position. With all Flickis tests complete, verify that all switches on this panel are in the down position. Place trim/autopilot disconnect in the disconnect position. Stick trim and autopilot are inhibited. The manual trim panel can still be used to trim the aircraft. Check that stick trim does not cause flight control movement or the relevant trim needles to move. Place trim/autopilot disconnect in the normal position. Stick trim is energized and the autopilot is operable. Apply stick trim to check correct trim operation. Verify that roll, yaw and pitch trim are centered. We now test the EPU. The EPU provides emergency hydraulic pressure to System A and emergency electrical power to the emergency buses. It is automatically activated when both the main and standby generators fail or when hydraulic pressure falls below 1000 psi. To maintain operating speed, the EPU uses engine bleed air. If bleed air is not sufficient, hydrazine is used as a booster. The green EPU run light illuminates when the EPU turbine is within the proper range and EPU hydraulic pressure is above 2000 psi. The yellow air light illuminates when the EPU is running on bleed air. Engine RPM should be maintained between 82 and 90% to prevent use of hydrazine. The yellow hydrazine light illuminates when hydrazine is being used to boost bleed air. Note that hydrazine is limited and is exhausted after approximately 10 minutes in normal use. It is important to land the aircraft within that time. Place EPU in the off position, then return it to normal. Check that the EPU generator and EPU PMG lights are off. With the aircraft on wheel chocks and toe brakes, increase throttle to 80%. Press and hold EPU/generator. Check the following lights: EPU air light on, EPU gen and EPU PMG lights off, 4 flickies power lights on. EPU run light illuminates after 5 seconds. If the light fails to illuminate, restart the test with a higher throttle setting. Release EPU/generator. Return throttle to idle. ECM is in the standby position. We will now test secondary control mode. Apply toe brakes. To select secondary control mode, place engine control in the secondary position. Master caution and the secondary caution light illuminate. The engine nozzle closes and the nozzle position indicator should report less than 5%, with 0% being completely closed. Verify smooth RPM operation in secondary mode. Note that RPM may be lower. Return engine control to the primary position. Master caution and the secondary caution light turn off. Nozzle position increases to more than 94%, with 100% being completely open. Return throttle to idle and release the toe brakes. We will now test speed brake operation. To test speed brake operation, we open the speed brake using the thumb activated slide switch located on the throttle. Open the speed brake. A 3-position speed brake indicator is to the left of the landing gear control panel. The indicator has 3 positions. Closed indicates that the speed brake is closed. A 9-dot symbol indicates that the speed brake is not closed. And striped lines indicate that electrical power is not being received. It takes 2 seconds to open the speed brake and 6 seconds to close it. Close the speed brake. To power the EWS, set threat warning to power. The green indicator illuminates when the EWS suite is powered. The search button enables an S symbol to be displayed on the RWR when the EWS is powered and it detects a search radar before its acquisition symbol will be displayed. If search is not enabled, the green S indicator on the TWA will blink at 4 Hz whenever the EWS detects a search radar painting the aircraft. The Activity/Power button is not interactive. Power illuminates whenever the EWS suite is powered, and Activity illuminates if the EWS is powered and it detects a search radar painting the aircraft. The Altitude button toggles between high and low altitude threat biasing, categorizing the SAM threat according to lethality at low or high altitude. High altitude biasing is the default whenever the EWS suite is powered on. Set the CMDS as desired. The Cmds panel forms part of the EWS suite and controls countermeasure management. The RWR and jammer toggle switches control automatic dispensing of chaff and flares. The RWR switch must be in the on position for the semi and auto modes to function. To coordinate release of countermeasures with the jammer pod, jammer must be in the on position. 4 categories of expendables are listed, though only chaff and flares are implemented. In the on position, the indicator displays the number of expendables remaining. Bingo level is set through the DTC or UFC. When bingo is reached, low is displayed with the number remaining. The indicator remains blank in the off position. 4 pre-programmed countermeasure sequences can be selected with the program knob. The selected program is activated with CMS up. A further 2 programs are also available. All 6 can be programmed through the DTC or the UFC when CMDS is in standby mode. Program 5 is activated by the slap switch on the left sidewall, and Program 6 is activated by pressing CMS left. The bid position is not implemented. The mode knob selects the CMDS operating mode. In the off position, the CMDS is not powered and countermeasures cannot be released. In the standby position, programs can be changed through the UFC, but countermeasures cannot be released. In the manual position, programs 1 to 5 can be manually released using the CMS. The program selected with the program knob can be activated with CMS up, and program 5 with the slap switch. In the semi position, the EWS will issue a counter prompt through the VMS when it considers that use of countermeasures is appropriate. Consent is then given with CMS back, at which point the selected program will be released once. Note that the RWR switch on the Cmds panel must be set to on for semi mode to work. In the auto position, consent is given once through CMS down until cancelled with CMS right. In the bypass position, 1 chaff and 1 flare are released with each CMS up command. Note that bypass is a manual mode and that no semi or auto functions are available. With the ECM switch in the operational position, the Go status indicator should illuminate, indicating that all systems are ready to be deployed. To run the Twp Built-In Test, press the System Test button. Review the indications on the RWR display which are relevant to the ALR/56 RWR. To check the missile launch and audio notifications, press the Missile Launch button. When satisfied the system is operating correctly, press the handoff button briefly to set the RWR to diamond float mode. In the diamond float mode, the diamond floats to the highest priority symbol, and sound for that emitter is heard continuously. To view the ALO page, press ICP2. The altitude low page is used to define values for the altitude advisory system. The number at the top right is the active steer point, which can be changed with ICP previous and ICP next. Coral low is mainly used to provide a low altitude warning. The value input is also displayed on the HUD to the right of the letters AL. This flashes when altitude is below Cara low. With the DCS, move the asterisks to MSL floor and enter the transition altitude with the ICP numeric buttons and press enter. When descending through the transition altitude, an altitude warning prompts a QNH update. Double left to return to the C and I page. To view the TACAN ILS page, press ICP1. Use this page to input TACAN and ILS settings. The system can differentiate between TACAN and ILS formats. To enter the TACAN frequency, input it with the ICP numeric buttons and press enter. Note the band to the bottom left. To enter the TACAN frequency, input it with the ICP numeric buttons and press enter. Note the band to the bottom left. X-ray indicates a ground TACAN, while Yankee indicates an airborne TACAN. To toggle the band, input 0 and press enter. To change the TACAN from T/R ground domain to A/ATR air domain, use the DCS sequence button. To enter an ILS frequency, input the desired frequency and press enter. And to enter the ILS course, dobber down with DCS to move the scratch pad to the course line, input the course and press enter. ILS on is displayed at the top right. If the ILS knob on the Audio 2 panel is turned to the off position, ILS off will be displayed and ILS will not be available. To view the bingo page, press ICP list and ICP2. VMS will call bingo at the joker or bingo fuel state. Bingo is the minimum fuel state at which the mission should be terminated. Joker is a fuel state sometimes used as a notification of approaching bingo. The second line indicates total fuel remaining. Fuel quantity select is in the normal position. This knob controls the fuel quantity displayed on the fuel quantity gauge on the right auxiliary console. In the test position, the aft right and forward right needles each point to 2000, while the totalizer displays 6000 and the fuel low caution lights illuminate on the caution panel. In the normal position, the aft left needle displays the fuel quantity in the aft left reservoir and A1 fuselage tanks, while the forward right needle displays the fuel quantity in the forward right reservoir and F1 and F2 fuselage tanks. The totalizer displays the total fuel amount available. The automatic forward fuel transfer system, trapped fuel warning and bingo fuel computation are only enabled in the normal position. In the reservoir position, the aft left and forward right needles indicate fuel quantity in the aft and forward reservoir tanks, while the totalizer displays total fuel. In the internal wing position, the aft left needle displays fuel remaining in the left internal wing tank, while forward right needle displays fuel remaining in the right internal wing tank, with the totalizer displaying total fuel on the aircraft. Note that fuel from the internal wing tanks feeds into the fuselage tanks, therefore as long as the fuselage tanks remain full, CG is not affected. In the external wing position, the aft left needle indicates fuel in the left external tank, and the forward right needle fuel quantity in the right external tank. The totalizer displays the total amount of fuel carried. and in the external centre position, the aft left needle points to 0, while the forward right needle displays the quantity of fuel in the centre external tank, and the totalizer indicates total fuel on board. External fuel transfer is in the normal position. In the normal position, fuel is transferred from the centerline external tank first, while in the wing first position, fuel will first be transferred from the external wing tanks. To indicate INS alignment is complete, ready flashes on the DED and align flashes on the hood. We are now ready to prepare the aircraft to taxi to the active runway. As always, feel free to like, comment and subscribe.